So again, we start with a new patch. Can press Control P. This works in VVV and VL. And then I save it beforehand, so that the VL document, which will get created, is on the proper place and everything. Examples. And now we call this new folder to connect all. And let's also call the patch the same way.
And if we are too fast, you just stop us.
Okay. And I will start again with the basic setup, so the rendering part in VVV. So we start again with a renderer, EX9. Okay, now again the middle click, not working, what?
Middle click on the input.
On the input, okay. Come on. Okay. To get the group and the point, the EX9 2D is the first one. Connected here. Okay, now to generate the points, we create a random spread, 2D again. Then we use a filter node here, Newton, so that the points so we generate point clouds in every other direction every few seconds, and Newton will kind of filter them, so we have a nice animation going on. Put it in here, and then with an LFO, we change the random seed. We can increase the count a little, I don't know. What's going on? And we can, I don't know, maybe 2 seconds, 3. And we just change the size here of the generated spread so that it fills the whole window. The window goes from -1 to +1. And so we get values in that range. So let's decrease the acceleration here. So now we have these little points moving around, and the idea is that we draw lines between them when they are in a certain distance, kind of a threshold value between them. So this is the moment where we will enter VL now. And like we showed before, this always starts, or the easiest way to start to create a VL node is from the template. So you double click again, and then you say V and space. Now it filters the whole node browser down to VL nodes only, and then we type template. And this time again we will use the value stateless template. And now don't just click on it, press Control, and then click. And then you get this clone dialog. Now it will make a copy of this template node. It will make a copy of it with the name we give it here. And we will call it connect all. 2D. And let's just remove the version. We don't need this. So then we say clone. What did I do wrong? Maybe there's a connect all already, is there? No. And now we press clone, and we can now right click on this node. And now we get into the VL editor, which opens up then. Okay, so now we have the VL node, and I will start by deleting all this stuff here. And also this pin, let's just get rid of it. The output can stay. Now I will create a new pin, and you create a pin by double clicking. Is one way to always create stuff is double click, go to the node browser, opens up, and in this time we just type in input. We want to create an input pin, and now we say enter, and it already calls it input, which is okay now. And then we will have another input, so we again type double click and then input, and this one we will call a threshold. You can also copy them, yeah, of course. Or you can also, for example, if you already created a node, let's say I have a plus created here, you can also click a pin and then do the double click. You also will get a pin. So this is different to VVVV. In VVV you just did this middle click thing, and then when you gave it a name, this patch got a pin on the outside, right? And we changed that in VL. In VL there's a distinction between pins and I/O boxes, so to say. So because we have constants, I/O box is like a constant value in the system, and the pin is something different. Data flows in there. So the reasoning is, for example, here I have this size xy, and I see that the value is 2, 2. But this is not necessarily true, because when this thing is connected from the outside, another value could go in. So we decided to switch this so that it's immediately clear where the data flows in from the outside and where there's constant stuff in your patch. That's why we separated this. Now let's get rid of this plus. So in this example, we want to iterate over all the points. And then for each point, we want to iterate again to check each point with all the other points. And when that distance to another point is below the threshold value, then we want to add it to our output collection. Okay, that's the whole idea of this thing. So, like I said, first we have to iterate over all the points which are coming in. So we double click again, and now we create the for each loop. So like explained before, we have two kind of loops. The for each loop, which will iterate for each input value, and then we have this other loop we showed before, the loop, which just iterates as often you tell it with an input count. But in this example, we can just use the for each loop. Usually it's a fine approach, because you don't have to do a count and I don't know what not, it just iterates. And now to get it to iterate, to do something, we have to create the splicer, at least one splicer input. So this splicer we showed before is the, when I click here, what the hell? So whenever you have a connection at hand, I know you don't see it properly maybe, but the loop will now show these 4 lines, where the outer ones are the splicers and the inner ones are the accumulators. So in this case, we click on the outer bar so that we create a splicer. And now I still have the connection at hand. And I will just leave it at this, and just for, I mean, I don't have to give it a name, but I will do it just for clearness here. I will call this just this, so that we can read it more easily. And here I create the second loop inside the other loop. Now we have a nested loop, so to say. And here I will iterate again over the whole thing, do the same thing. And this one I will call, here in the double click to the right side of such a splicer, you can give it a name, a descriptive name. And this one I will call other. And Yeah, now it's still everything is in this grayish thing, like we said before. VVVV can't deal with generic data. Meaning here we can read it says the type of the input is a sequence of t. T is a parameter. In this case, we don't want this, so we will set a type annotation here. I can set the type annotation here, or I can set it inside here, but I will do it just here, and I will again type spread. And now with these, how do you call them?
Middle click, or how do you get to the type?
Oh yeah.
Sorry.
Middle click
Yeah.
or right click.
You can either right click and say configure, okay, or faster way is to just middle click to get to this menu, okay. So now I type here spread, and where's the? Now you have to create these. How do you call them? Smaller and greater signs. So yeah.
And greater than smaller.
And now inside you type vector 2. I mean, if you have an error here, the whole thing will turn red. If, for example, write vector 2, if it's, the casing is very important. If I write it wrong, for example, then you have something like this red thing where it will tell you not found spread of vector 2. And
so vector 2 and not a vector of double or float 2?
We called vector 2, vector 3, and vector 4 are they are all internally use the float as a component type. They use float. Basically because we imported it. So the vector you're using right there is imported from SharpTX. It's a quite famous library which is used for DirectX rendering and so on. And there it is like this. So, of course, you could also define a vector which is generic, where the component is of t, and so on. But usually in 2D and 3D drawing, you just need these vector 2, 3, or 4. You're fine.
Can I find the list of types somewhere quickly?
A list of types?
Yeah, what kind of type the input?
Yeah, if you...
There is no drop down.
there is a drop down, no? You see? Yeah, but I think it's, this drop down is not so sophisticated, because the moment I type this smaller sign, it doesn't help me anymore.
So
But,
basically, sorry.
yeah.
So basically, it's always a vector 2 when it comes from the form.
No, it's either a float, 32, for example, or a vector 2, a vector 3, a vector 4. So, what you have to understand is that VVV has a few defined types. Like VVV has a value which is internally a floating point number. Then it has color, string, and what else?
Integer.
No, it doesn't. VVV doesn't have integer. It just has floating point values. And these are the only types VVV knows about. So, yeah, and matrices, yeah, transforms. So, these 4 or 5 types you can put in here, and it will translate. And for example, if I type in vector, it will create a floating point pin on the outside, but it will tell VVV that it has this dimension of 2. But it's still just a value pin for VVV, okay? So now I type what I wanted to do, spread of vector 2. I just put this type annotation here once, so that we are done here. And now it's not so transparent anymore, not so grayish. And now we iterate here, and so for each particle, so to say, we will then iterate again, and then we will do the distance check between the two of them. So I say distance math, yeah. So the distance between this and the other one. If this distance is smaller than our threshold value, then I want to add those 2 points. So in the end, we want to draw lines between these points. And for the line, we need the starting point and the end point. So we do an add here, type in add. Then it asks me from what type, and I say spread. Okay. And now I use a little trick here. I could do the following now. I could say, okay, I add this, and after that I do another add, spread. Now I connect this one here and say other. So I could build it like this, but there's a shorter version for it. You can right click on some nodes. Some of them have this option where you can say configure. This is not what I wanted to do. Sorry. So some nodes have a dynamic input count, like this add node. And you can select the node and press Control and plus or minus. Then you see it creates additional input pins. Okay. There's no, I mean, you have to know on which nodes this works, so you can always try to increase the pin count. But I think if you right click, it also should say here in the menu, increase pin count, yeah. So of course there should be a nicer way so that you see immediately whether you can do this or not, but right now it is like this. So I will increase the pin count by 1, and then I can, so to say, patch this in a little bit more compact fashion. So I can remove that guy. And now the question is, yeah, well, I added this, but I didn't say where to. So it still has this one input, which is a spread. And this is our final result, so to say. And now we will use this accumulator function of the loop. So the idea is that we start from the outside. We start with an empty spread. And then whenever this condition here applies, we will add those 2 values to this spread. And in the end, we output this whole thing and connect it to our output pin. So I will start so that we can read it easily. I say empty spread again, put it here on the top. And now I do connect the whole thing through. So I connect here to this second bar, the accumulator bar. Now I get this diamond kind of thing. I do it again on the inner loop. Now I connect to the add here. And now we have to finish the connection so that this whole value gets written back. So I connect it here, and now the final result I will output to the outside. So so again, like I did here with this and other, I can give it a name, this accumulator, so maybe it's easier to read. So these are our line points. And as you see, as I typed the name, the name was already added down there, because this guy and this guy, they are in a relation, so to say. They are together. They represent the same thing. I mean, we could draw this already, I think. It's not finished yet, I know, but...
Did you always connect the empty node to the diamond of each?
Whether I have to do this?
Yeah. Did you always click on
The lower bar. No, you don't click on this icon, you just click on the bar.
So if I do it again...
I think the question was if you always have to do it like this. If you always connect the empties to the diamond. But
No.
Because when you have
No.
this, it stays away.
The purpose of the empty spread at the top, though,
Mm-hmm.
is that to So if you didn't do that, you couldn't.
It wouldn't matter. It wouldn't matter. I could delete it.
Okay.
In this case, it wouldn't matter because it would take as a default the empty spread.
Okay.
So whenever something is not connected, the system will try to find a good default. They are all defined at some point. It's somewhere, but this is not the purpose of this workshop. But
But you could create an accumulator just by creating a diamond at the bottom.
yes.
Yeah, and that would be
Yeah.
actually spread.
But this way, I think it's easier to read the whole thing, like what is going on. We start with the empty spread, the initial value, and then we kind of pipe it through the two loops and add stuff to it, and then put it out again.
And how big is the empty spread? Is it like
How big?
nothing, or
Yeah,
is it infinite?
it's just a spread with 0 entries.
Okay, with zero entries, and so that will be added.
2.
Okay.
Yeah.
So
Every time we call
comes-
add, the spread count will increase by 1.
Okay. Okay.
So we start here, and you will have 0 entries, right?
Okay.
And then after the add, we add 2 items, item 2. Then we'll have in the first iteration we'll have an item count of 2 in the spread.
Okay.
Now we pipe it back, and it comes back up here, and the same thing again. Then we have 4 and 6 and so on. Okay.
Okay. And when will it be put out? Will it be put out after the 2 to the output, or
No.
how long will it be accumulated?
So
until it will
the
be the
yeah,
output?
exactly.
When all iterations are finished.
So here we have a nested loop. Okay, inside
Yeah.
this loop also iterates over all the inputs here because of this connection here.
Yeah.
And so the empty spread comes in the first iteration. Then we add the 2 values. Now it has 2 entries, and now the loop is not finished yet, the inner loop. So this value here, I can also give it a name. Again, inner line points. Okay. Now after the first iteration of the inner loop, this value will get passed up again here. And the second iteration of the inner loop starts. And then it will again add something. And this will go on until the whole loop for each is done.
Okay,
And then this final value will come out here. Let's say with 40 or 80 entries.
Whatever the input, however many are in the input up the top.
Yes. It depends on how often this loop iterates, depends on these splicer guys. So if I don't have any splicer here, the thing will not iterate at all. Okay? So for each loop, how often it iterates depends on the splicer input. You can have many of them. If you have many, it will go to the minimum. So let's say I could put in more stuff here. For example, I have another input, okay, and I could also iterate over this one at the same time. But let's say the first one has 100 entries and the second one 10, and I iterate over both of them, then the loop will stop at the minimum, so it will only iterate 10 times then.
Yeah, and the accumulator has no influence on that.
Yeah.
It is just some place where you can store stuff and read
It's
it.
like a pen. So
It's like last time it helped that someone said, yeah, it's like a local variable, a loop variable. Okay,
Yeah.
I don't know if you are familiar with programming, textual wise. No, okay, then it won't help. So, but there's a last thing missing. I have this. We have this distance calculation going on, and we only want to add stuff here if this output is true. So again, I use a special feature here that nodes can have an apply pin. So you right-click, say configure, and then you have to right-click on the show apply. And this pin is kind of special because it will, if it is true, if the value of it is true, the whole thing will execute. If it is false, the system will do a bypass. It will simply put this input value here from the input to the output. So it's kind of a conditional execution.
Can be patched with a switch?
With an if, you can do it with an if.
There's also the other another construct, the if region, where you can do the same thing. This is just sugar, so that you can have small patches still. So
if we were to do it with an if region,
yeah,
then we would just put it around the add.
Yeah.
yeah. So I can show it just outside here. Let's say I have an add spread. Okay. Now I would say here, yeah, surround with if is one way. The other one, I start with the if and put this add in here. And this would be the apply pin, right?
Yeah, okay.
Du kannst auch kurz sagen, wie man es rein und rausdragen kann.
Yeah, klar. And here I again have to we have, it's very similar to the accumulator and the loop. I have to output this value. And now you see, this would be my spread here. And what happens is that we, now let it connect it differently. Like we start with this value, in case the condition holds, it will go in there, do the execution, and then it will output stuff. If it doesn't, it will just pass the value from here to here. So this is basically what the apply pin does. Yeah. Okay, I just connect the smaller to the add. Now we are basically finished already. Now we can go back to VV and draw this stuff by creating a line, AX9. Now we put the output XY. I think the line is meant for 3D space, so we have to create out of these 2D vectors, 3D vectors. I do it with XY Z, right? This one? Yes? Wow.
Ja.
Was ist jetzt passiert? It's called XY and the big Z. Now we just connect it through. This one goes to vertices. Now the bin size, I think, is 2 because we said we have a starting point and an end point, each line described like this. Bin size here. What else? Nothing more. Now I also connect Newton here. This threshold value, I would change it to something. Oh. And now just draw these lines. You see something working now. So if I change the threshold, yeah.
So this link is from here, from the output. Maybe you can arrange it a little bit better.
Hmm? Yeah. A little more space here. Okay.
Can you also comment in VL?
Wie?
Can you comment in VL?
Yeah, you just double click and write something, foobar, and then you press enter. Don't click, also I think in VV you can also click somewhere else, but then the whole thing is gone. So remember to press enter. Something like.
So you have to save VL and VV separately.
Yeah, don't forget to save. Yeah, you have to press save on both windows.
It's a different file. Yeah. And you can also change on a comment. You can also change the size. I think again do a right click on it and then configure. Then you can change the font size to. Okay, now there's one little optimization we can do here, because right now what happens that we create the lines twice. So you showed it the last time very nicely with the cross node, right?
Ah, yeah, yeah.
So I just show you what's going on. Cross to D.
Linear spread.
Linear.
Vektor 2D Drawing. Jetzt X und Y Output. Also 2D Output.
Wie viele Werte kommen denn da gerade so raus aus dem Connector-Bereich?
1000 ungefähr.
Ja, so passt alles ab.
Yeah, you don't have to patch this, it's just for
Visualization. Das ist Linear Spread noch. Jetzt können wir mal stellen. Mehr als Spread Count ist
So what's happening right now with these two nested loops? Let's say we have, what is our spread count here? 40. So we have these 40 particles, and what's happening right now is that we, the outer loop, you can think of it as the X component and the inner loop as the Y component here on this diagram. And so we are checking each item twice right now.
and with itself.
And
as well.
and with itself as well. So, for example, and with the crossed node, I can easily show it. I can say include equal no. So basically, we wanna do this, that it doesn't check the diagonal.
So you don't check the same point with itself.
So
again.
that don't check my distance on my own will always be 0. So to do that in VL in such a nested loop construct, you just create. Now again, the loop has a special input pin inside, which is not shown by default, but you can create it, and you type in index here. You can do it inside the loop. Now you will get this little pin here. You can copy it, put it also here. I have a little problem with. And this will, for each iteration, give you the count in which iteration you are. And now so to say, to kick out the diagonal, I can do an unequal here, not equal, and connect it like this. And now we only apply our function, the add, when the threshold value is okay and when we are not on the diagonal. So now we filtered out all these checks.
So you don't want to check point 10 with point 10. So if the index is the same, you don't do the check. You don't add it.
But we also don't want to do the other checks around. So we like check from A to B and then later on again from B to A. We don't need that either. So in the end, what we want to have, something like this, okay? And for that, I just replace here the not equal with a smaller node. And now the output should still look the same, but when you hover over the count of lines here, you will see it should be half of it or even less, because we don't have the double lines in there anymore.
Can you break from the loop?
Yeah, you can break.
During the calculation.
You can. There's a pin. It's called break. You can put it here, and when you connect it, it will go in.
Stop the loop. Yeah. Double click the node.
To replace,
Yeah, double click and then you see the.
just double click.
And then,
This is
du musst dann die Maus anklicken.
now you see the, if you double click a node, then you see the choices you made before, like you said, smaller and adaptive, and now you can, for example, remove the category here, choose another one, or remove that one, and type something completely new here. So this node browser works kind of like a choice system. So you say, for example, I want to have join, for example, some node called join, and now the system says, well, there are many joins. Which one? And it will ask you again and again as long as it's ambiguous, so to say. And the moment it's clear that there's only one node left, it will say, okay, now I will take that one. So this is kind of how this system works here. And so you always have these choices down here, and you can remove them again and get back to the thing you were before.
There's no quick move.
Quick move.
Using cursors and shift doesn't work inside the
I think cursor works.
Cursor works,
But shift should also do something.
It's control.
Control. Yeah, control.
And it also has, for example, I think you don't see this when I hover over it, it will tell me how long the execution takes. If you want to see that also, you have to go, wait a minute. Up here to the menu, and then there's something called settings here in the main menu. And there you will get, it opens up the XML file, the config file. And there you have something like show,
Timing.
yeah, where is it? There, tooltip show timings, and when you set that to true, then you will also get these timing values, as you see in my tooltip here. Where it says it takes 1 millisecond to execute the whole thing. Which is not entirely true, because the moment I do that, it will go into a debug state internally, which is slower. But it gives you an idea where the performance is going to. The patch window, if you middle click up there like in a browser, the tab up here, then you can close it, and maybe if you open it up again, no? Yeah, well, the next time you start up it will.
Here it works. You don't forget to save the settings file, right? You have to save it.
It's a break.